Hi, my name is Sophia Carmen, and for My Page, I'm going to be sharing a few things that I have done recently that I find very interesting. The first thing I'm going to be talking about for the My Page is cubes in space. You may be wondering, what is Cubes in Space? Cubes in Space is an international contest that's run by NASA. The objective of the contest is to make a small experiment that can fit inside a 2x2-inch cube. The age range for this contest is for 11 to 18-year-olds, so the projects vary in all ranges of difficulty. If chosen, your cube will then go up into space and you get to see what the results are from there. For our project, my partner and I decided that we were going to see if crystal filaments could still be grown in space. But after several failed attempts of finding it, we stumbled across a website that claimed to be selling graphene. At the time, my partner and I didn't know what graphene was. But after doing some research, we found out that it's a fairly new material, found only about 2 years ago. Scientists say that pure graphene is stronger than steel, lighter than air, and more conductive than copper wiring. Pure graphene is made up of carbon nanotubes. Carbon is one of the most available materials that's in this world. Also, it's what makes up most of Mars's atmosphere. After my partner and I found out all of that information about graphene, we decided to change our experiment to the effects of microgravity on the conductivity of graphene. After thinking about it some more, we realized that if our experiment was a success, then you could use that graphene to potentially colonize Mars. We thought that since carbon was the main element in both graphene and in the Martian atmosphere, you could grow graphene and then use it to 3D print houses and solar-powered technology. After we ordered all of our materials, we actually started to make the project. We started with the Arduino. We wrote code for it, and that would measure to see how conductive the graphene really was. To measure the conductivity of graphene, we took 2 different copper wires and then put a piece of graphene between the two. We then hooked up that long wire from the Arduino and the meter that measures the voltage. After we would send the spark through, we would see if the graphene acted as a conductor or not. After the results of that test turned out to be positive, we moved on to see how we would fit the batteries inside. At first, we tried using battery packs, but those turned out to be too big and wouldn't fit inside the cube. After that test failed, we tried using tape, but the wires kept falling out and so did the batteries, and it just wasn't working overall. Then, we found out about shrink tubing. We used the shrink tubing to put the batteries together and also connect the wires to them. We had tested it several times and nothing ever came undone. Then came the really hard part. Although it didn't seem like it at first, getting all of the materials to fit inside the cube was really hard. We tried multiple times and got kind of frustrated with it until we finally found out a way that worked and everything could fit inside. The cube was so small and that made getting everything inside really difficult, but it was like a really fun puzzle that was also really challenging that worked out in the end. After packing up our cube and sending it to NASA, we had to wait. We waited for about a month before we got the good news. We won! Out of everybody in the world, they wanted our experiment to go into space. It was a huge honor, and after we found out that we had won, we went to celebrate with our parents. In the weeks to come, my partner and I would give presentations on cubes in space to prospective parents, to our classmates, and to everybody else that would listen. Currently, our cube is waiting in the NASA payload to be launched in 2018. The second thing that I will be talking about in this video is a recent science project that I did, which was taking apart a Walkman. So here's me trying to take the back off of my cassette recorder so that I can get to the breadboard, and there it is, and now I am trying to get it unscrewed so that I can get to the gears that are underneath the breadboard and see how that all works. It was actually really hard to get the breadboard off because there were a lot of really well hidden screws, but in the end I was able to get it, which is great, and that's what the cassette recorder looks like without the breadboard on it. So here I'm trying to get the speaker out, which was actually really hard because the door wouldn't open all the way, so I had to break it. But in the end, I was able to get out the speaker. This is the cassette recorder with most of the parts taken out. Here I'm trying to get out all of the gears and the buttons to see how they all work. In the end, I was able to take out all of the gears and the buttons out, but unfortunately, I couldn't put it all back together, but it was still really great to see where everything went. The reason I wasn't able to put the Walkman back together was because some of the pieces got broken when I took it apart. Thank you so much for watching, and I hope to see you next year at Nueva.